At the moment, more than 80% of our energy is derived from burning fossil fuels. So what can we do with the carbon dioxide that's generated from those fossil fuels? The easiest, in terms of the simplest technology, is simply to take the flue gas from a power station and bubble it through a solvent. These are normally amines. If we bubble the carbon dioxide through this, the carbon dioxide is dissolved, and so it's captured by the amine and is not released to the atmosphere. Once the carbon dioxide has all been dissolved, you can then heat the amines back up again. Pure carbon dioxide is released. That can be piped and then injected deep underground. If you're going to build a power station from scratch, you might try something more innovative, and there are a number of different possible technologies. One is what's known as an oxy-fuel plant.
So we are here in the worldwide first pilot plant for the oxy process, where we try to make electricity from coal without emitting CO2 in the atmosphere. The oxy-fuel process means that we burn the coal instead of surrounding air with pure oxygen, and so have a really CO2-rich flue gas, which we can compress and clean up and then bring to a storage site. The oxy-fuel combustion works very well, and nowadays we are stabilizing the flue gas stream so that we can make good quality of CO2 at the end of the process. So until now it works quite good.
In the next 20 years, next 2 decades, the amount of CO2 we produce, and we're not going to change things very much in the next 20 years. If we liquefied it all, and that's what you do with it, you pump it up to the point where it makes CO2 into a liquid, the amount would fill our Lake Michigan. Now, if you go home and look in your atlas, the volume of Lake Michigan, it's huge. That's the amount we would have to put away. So this is a huge thing.
We are at Ketzin, which is in Brandenburg and about 40 kilometers away from Berlin, the capital of Germany. We are here because I want to show you our exciting storage site for CO2 for only scientific purposes. Many people have in mind like big holes underground, but that's not the story. The truth is that we are pumping it into that type of rock. That is a sandstone, and it has about 20% pore space. So in 1 cubic meter, roughly 200 liters of literally any liquid can be stored.
The temperatures and pressures typical of injection sites, the carbon dioxide is actually liquid-like.
When talking about CO2 storage, you're talking about long terms of time because you want to keep it underground. So we're talking at least some thousands, 10,000s of years. So that would be the lifespan of such a storage site. We're pumping down CO2 at the moment. And you can also hear it when you put your ear against the floor line. You hear the CO2 coming through it. The vision would be, of course, to store most of the CO2 which is produced from coal-fired power plants, to capture that and to store it safely underground. And the facilities would pretty much look the same like here. Germany emits about 800 millions of tons of CO2 in 1 year. We have the storage capacity for about between 30 and 100 years.
And carbon capture and storage is likely to cost no more than the most efficient wind farms or indeed building nuclear power stations. And so the vision is that by 2020, this is beginning to be applied at industrial scale in a large number of sites. And then as the century proceeds, our use of fossil fuels decline as we're able to provide more and more energy from renewables.